Hi guys, let's look at the next question. Next question is question number 4. Find the value of k for which these two lines are perpendicular to each other. So since these two lines are perpendicular, which means m1 into m2 will be equal to -2. So let's start writing. Since L1 is perpendicular to L2, therefore slope of L1 multiplied with slope of L2 will be equal to -1. So let's call this line 1 and let's call this line 2. So let's look at line 2 first. So line 2 is 2y is equal to 5x plus 5, 5x plus 5, which means y is equal to 5 by 2x plus 5 by 2. Let's compare this with y is equal to mx plus c. Therefore slope of line 2 will be equal to 5 upon 2. Let's look at line 1. Line 1 is 5y is equal to kx plus 4, which means y is equal to k by 5x plus 4 by 5. Comparing this with y is equal to mx plus c, I get slope of this line is equal to k by 5. So since m1 into m2 is equal to -1, let's put values. So k by 5 into 5 by 2 is equal to -1. 5 and 5 gets cancelled, which means k is equal to -1. That's what they wanted. We've solved this question. Very simple one. Let's look at the next question. The next question is question 5. It says straight line through P, -1, 4 and Q, 5, -2 intersect the coordinate axes at A and B. So A would be x0 since it lies on the x-axis, and B would be 0, y since it lies on the y-axis. We need to find the equation of AB. So equation of AB will be equal to the equation of PQ because they're the same line. Those are points lying on the same line. So for equation of PQ, we need the slope of PQ. So slope of PQ would be given by y2 minus y1, which is -2 minus 4 upon x2, which is 5 minus -1, which means 5 plus 1. That's -6 upon 6. That's -1. So slope of PQ is equal to -1. Therefore, slope of PQ is equal to slope of AB, which is equal to -1. Now, equation of AB will be given by y minus y1 is equal to m times x minus x1. So y minus y1. P lies on this same line. So y minus y1, let's take 4 is equal to m, which is -1 times x minus -1, which is x plus 1. Y minus 4 is equal to -x minus 1, which means y plus x is equal to -1 plus 4. That's 3. So this is the equation of AB. That's what they wanted. Next step is we need to find the coordinates of A, B and M. Now since A intersects the x-axis, so let A is equal to x comma 0 and B is equal to 0 comma 1. Since x, it lies on the x-axis and it is on the line y plus x is equal to 0. So put x comma 0 in the equation y plus x is equal to 3, which means x is equal to 3. Therefore, A is equal to 3 comma 0. Similarly, put 0 comma y in y plus x is equal to 3. X is 0, which means y is equal to 3. Therefore, B will be equal to 0 comma y, which is 0 comma 3. So they wanted us to figure out the coordinates of A and B. Done. Next, coordinate of M. M is given as the midpoint of AB. So using midpoint formula, we get M will be equal to x, sum of x coordinates of this, which is 0 plus 3 upon 2 and 3 plus 0 upon 2, which is 3 by 2 comma 3 by 2. So that's the coordinate of M. Next, let's look at the question question number 7. So question 7 says, show that these can be vertices of a square. Find the coordinates of D if ABCD is a square. So without using the coordinates. Perfect. So let's look at, let's say this is the coordinates. So let this be A, which is 3, 2. Next is B, which is 6, negative 2. Next is C, negative 2, negative 5. And this is D, we don't know. So A is given as 3, 2. B is 6, negative 2. And C is 2, negative 5. Perfect. So if this is a square, then this angle will have to be 90. Right? So which means AB will have to be perpendicular to BC and AB will have to be equal to BC. So using, let's do the distance formula first. So using distance formula, let's find AB. AB will be equal to y2 minus y1. So that's 2 plus 2 whole square. So I've taken this as y2 plus x2. That's 3 minus 6 whole square, the square root of this. So this is 4 square, which is 16, and this is negative 3 square, that's 9. So AB is equal to 5 units. Perfect. BC. BC would be y2 minus y1. So let's take negative 5 minus of negative 2, that's plus 2 whole square, plus x2, that's 2 minus 6 whole square, the square root of this. This is negative 3 square, that's 9. This is negative 4 square, that's 16. So this is equal to 5 units. So now I know that AB and BC are equal. So this could be a square. Now let's check the slopes. So first let's find the slope of AB. Slope of AB would be y2 minus y1. So this is 2 minus negative 2, that's 2 plus 2 upon x2, that's 3 minus 6, that's 4 upon negative 3, right? 4 upon negative 3, which means negative 4 upon 3. Done. So this is negative 4 upon 3. And let's find slope of BC. BC would be y2 minus y1, that's negative 5 minus negative 2, that's negative 5 plus 2 upon x2, that's 2 minus 6. So this is negative 3 upon 4. Oh, negative 3 upon negative 4. Sorry, 2 minus 6 is negative 4. This is equal to 3 upon 4. So let's check if AB is perpendicular to CD. So since slope of AB multiplied with slope of CD is equal to negative 4 by 3 into 3 by 4 is equal to negative 1. Therefore, AB is perpendicular to CD and AB is already given equal to CD. Therefore, A, B and C can be vertices of a square. Done. So they can be. We'll just have to figure out D. So yes, they can be. We've solved this part of the question. Find coordinate of D if ABCD is a square. So let D is equal to x comma y. So if D is also making an angle of 90 degree, so if AD is making an angle of 90 degree with CD, and if CD is making an angle of 90 degree with BC, we can find the slope of AD and multiply it with both of them. Perfect. So let's find slope of AD. So slope of AD will be equal to, and D we've taken as x comma y. So it will be equal to y minus 2 upon x minus 3. Since AD is perpendicular to AB, which means y minus 2 upon x minus 3 into slope of AB, and slope of AB we've calculated as negative 4 upon 3 should be equal to negative 1. Let's cross multiply and let's multiply and see what do we get. So I get negative 4y plus 8 upon 3x minus 9 is equal to negative 1. Cross multiply, negative 4y plus 8 is equal to negative 3x plus 9. Let's take 3x on the same side. So this will be 3x minus 4y is equal to 9 minus 8, which gives me 1. So that's my first equation. Next, since CD is perpendicular to BC, therefore slope of CD multiplied with slope of BC should be equal to -1. So now let's find the slope of CD, and then let's try and find let's multiply them. So slope of CD would be y minus -5, which means y plus 5 upon x minus 2 multiplied with slope of BC. We calculated slope of BC as 3 upon 4. This should be equal to -1. So this is 3y plus 15 is equal to, that's 4x, so that's a -4x, and that's 8, so that's plus 8. Yes, -4x plus 8. Let's take x on this side, so that'll be 4x plus 3y is equal to 8 minus 15. That gives me -7. Perfect. So 4x plus 3y is equal to -7. That's my equation number 2. We'll have to solve these two simultaneously to get my value of x and y. So I know if I multiply this with 3 and multiply this with 4, I will get the coefficient of y equal. So let's multiply. What I get is 9x minus 12y is equal to 3, and this I get is 16x plus 12y is equal to -28. Let's add. This becomes 25x is equal to -25. Therefore x is equal to -1. So put x is equal to -1 in, let's say, equation number 1. If I put this in equation 1, what I get is -3 minus 4y is equal to 1, which means 4y is equal to -4, which means y is equal to -1. Therefore d is equal to -1 comma -1. Done. So we found the coordinates of D. Next, without using the coordinates of D, find equation of AD. So since AD is parallel to BC, since this is a square, opposite sides are parallel, therefore slope of AD will be equal to slope of BC, which is equal to 3 by 4. So equation of AD will be given by y minus y1, it's passing through a, which means y minus 2 is equal to 3 by 4 times x minus 3. Let's cross multiply, and what I get is 4y minus 8 is equal to 3x minus 9, which means 4y is equal to 3x minus 9 plus 8, that's minus 1. This is 4y, my mistake. This is 4y is equal to 3x, and yeah, this is 4y is equal to 3x minus 1. So this is equation of AD. This part also done. Next, we need to find the equation of BD. Oh, that's a very long question. Let's look at how can we find the equation of BD. So we know that AD and BC bisect each other at 90 degree, which means slope of BD will be multiplied with slope of AC will be equal to -1. Perfect. So let's find the slope of AC. So since AC is perpendicular to BD, therefore slope of AC multiplied with slope of BD will be equal to -1. Now slope of AC would be 2 plus 5 upon 3 minus 2 multiplied with slope of BD will be equal to -1. 2 plus 5 is 7, and this is 1. So this is m into slope of BD is equal to -1. Therefore slope of BD will be equal to -1 upon 7. Now we know the slope of BD and we know the coordinates of B. Therefore equation of BD would be given by y minus y1 is equal to m times x minus x1. Let's substitute values. Y minus y1, which is minus of -2, so y plus 2 is equal to -1 upon 7 x minus 6. Cross multiply, 7y plus 14 is equal to negative x plus 6. Let's take x on one side. So 7y plus x is equal to 6 minus 14. That's negative 8. I can also write this as 7y plus x plus 8 is equal to 0. Perfect. So let's look at the next question. The next question that we'll do will be question number 8. Let's look at question number 8. A line through the origin meets the line x is equal to 3y plus 2 at right angle at point x. Find the coordinates of x. Okay. So line through origin meets this line. So this has a positive slope. So let's just draw a rough diagram. So a line through origin meets this line. So at 90 degrees. So line through origin is given line. It meets this line is x is equal to 3y plus 2 and it meets at 90 degree at point x. We need to find the coordinates of x. Perfect. So let's find the slope first. So x is equal to 3y plus 2. It means 3y is equal to x minus 2, which means y is equal to x by 3 minus 2 upon 3. Comparing this with y is equal to mx plus c, which means slope is equal to 1 upon 3. So the slope of this line which is given is 1 upon 3. Since given line is perpendicular to required line, not required line, line passing through origin, which means m1 into m2 will be equal to negative 1. So therefore slope of line passing through origin, which is by m2 through origin, will be equal to negative 1 upon m1, which means negative 1 upon 1 by 3, which is equal to negative 3. Perfect. So this, the slope of this line, which what we are talking about, this line's slope is negative 3. Now we need to find the coordinates of this. For that we'll have to find the equation of this line. So equation of line would be y minus y1. Since it's passing through the origin, the coordinates would be 0, 0. So y minus 0 is equal to m, negative 3 times x minus 0. Y is equal to negative 3x, which means I can also write this as y plus 3x is equal to 0. So this is my line number 2. This is my line number 1. We will have to find the intersection, which means we will have to solve them simultaneously. So let's write the first line will be, first line becomes x minus 3y is equal to 2, and the second line is 3x plus y is equal to 0. I notice that the coordinates coefficients will be equal if I multiply this with 3. So let me multiply this with 3 and I get x minus 3y is equal to 2 and 9x plus 3y is equal to 0. This gets cancelled. 10x is equal to 2. Therefore x is equal to 1 upon 5. So put x is equal to 1 upon 5 in equation 2 and I get y plus 3 upon 5 is equal to 0. Therefore y is equal to negative 3 upon 5. Therefore coordinates of x are 1 by 5 comma negative 3 upon 5. Perfect. So we found the coordinates of this point. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.